Hello, my name is Adam. Today I'm going to be talking through the fuzzing feature of the FREE-WILi, particularly in the serial menus. So to start off, I am in the FREE-WILi GUI here. I'm in the GUI version 12. You can see my display processor is running version 55 and my main processor is running version 72 to sort of date where we're at compared to when you're watching. So let's get started by taking a look at what is the fuzzer. I'm going to do that by going into a submenu and using the help option on the fuzzer. So if I do H-Z, it'll tell me a whole load about it. What we're mostly interested in, just to start off, is this top line. We will go through the rest of this in this video. But to start off, what is the fuzzer? The fuzzer can repeatedly call menus at a specific interval. The menu calls can have programmable arguments. Okay, that's as simple as the fuzzer gets. So it lets us call one of these menu options a certain number of times at a certain interval and play it arguments, give it arguments. So let's test that out just to start with numbers to speech, n. So how does that menu work? If I do n, it just wants me to enter a number. I can enter the number 3, let's say. 3. And there we go. It played the number 3. If I wanted to fuzz that option, I could do Z to fuzz. Enter the menu item, repeat count, time in milliseconds, and arguments. Okay, so let's do N for numbers to speech. Let's just repeat 5 times, once per second. And let's just repeat the number 3. 3, 3, 3, 3, 3. And there you go. That's as simple as it gets with the fuzzer. You can also see over here, this is my events panel, a little bit covered up by the camera here, but that is showing what commands are being entered. But yeah, that is the simplest use of the fuzzer. That's basically what it says here in the basics. You can enter the menu letter or repeat count and the arguments, and they give an example of T, 10, 125, very similar to what we just did. But let's get into the advanced and take a look at what the fuzzer is really capable of. So, through escape characters, the arguments can be dynamic. For example, you could ramp byte values in a radio message. The following escape characters are supported. You can do a pound symbol for a list, which alternates between items in a comma-separated list. You can do a $ for a ramp, ramping from an initial value between a min and a max with a step. You can do an @ sign for random numbers between a min and a max. And then down here we've got 2 modifiers for formatting, ~n, you enter in the value of n, and it formats the outputs of one of these commands as n bytes. So let's say I did ~1 and then did a random number. The random number would return a single byte formatted in hexadecimal. And then similarly, this ampersand here makes the fuzz value hex formatted. So it's not worried about how many bytes it takes, it's just going to take the output and make it hex. But yeah, we'll go through and kind of do examples of each of these and mixing them together and see what we can do. So let's start out, let's go back to the numbers and let's just make the fuzzer count from 1 to 9. So we could do that with ramping. We could ramp from an initial value between a min and a max with a step. Let's go back to fuzz. We want to do numbers to speech. We'll do 10 numbers, right? Repeat 10 times, once per second. And what's our argument? Well, to do a ramp, we need a $. We're going to ramp from an initial value. We're going to start at 0 between a min and a max. So 0 and 9 will be my max, just because we're 0 indexed going to 10, with a step size. We're going to make that step 1. And then what's not shown in here or in any of the examples is this works a lot better if you close what you started. So for ramping, it takes the $. You want to add one more space here and add another $. It makes it work a lot more consistently in my experience. So
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
There you have it. We counted from 0 to 9. We can get a little bit fancier than that. We could fuzz. Let's do the same style of thing. Instead, we'll do even numbers only. So let's repeat 5 times, once a second, step 0, 0 to 9, but with a step size of 2. So we only hit the even numbers.
0, 2, 4, 6, 8.
And there we go. Yeah, so that's how ramping works. what do we want to check out next? Let's help fuzz menu again. Why don't we check out random values next? We'll do the @ sign. So set a random value between a min and a max. But let's get away from text to speech. Let's go to the GUI functions, and we can do that. This example with the board LEDs. So first off, how does setting a board LED work? If I do S, it wants me to enter the LED number, followed by R, G, and B values in decimal from 0 to 255. So let's say LED 0, let's make it a little bit red. Red, green, blue. And there we go. So how can we play around with fuzzing this? Let's start off and not get too crazy. Let's fuzz. The menu item is S. We're gonna do this, let's just do it 5 times. We can do 100 millisecond intervals this time. And let's see, let's stick to LED 0. You know what, let's not. Let's make a random LED a certain color. So we can do random between 0 and 6. Don't forget to space and close that off. And then let's just set it to a little bit green. That didn't work. What did I miss? Yes, I used the ramp function, not the random function. Let's try that again. So S5, 100, @ sign, 0 to 6, another @ sign, 0, 100, 0. Let me copy this so we can keep playing with it. And there we go. We hit LEDs 3, 2, and 1 and got them to that green color. We can, of course, we've got multiple arguments. We can set random numbers multiple times. So why don't we do that again? But this time, let's set all the colors randomly. Let's do @ from 0 to 100. And I'll just copy that for red, green, and blue. Let that run. And there we go. We got fully random colors to a fully random LED. We can mix different types of commands, right? So we don't need to randomly choose the LED. Maybe we want to set every LED to a random color. Ooh, I ruined my copy paste. It's okay, I've got a backup one on the side here. So let's see what's different here. I still got the 0 to 100s for the R, G, and B channels, but now I'm using a ramp function to choose between LEDs, 0 and 6 with the step of 1. So this time we're going to set every LED to a random color. And go ahead. Oh, I have it set to take a full second to do it this time, but yeah, and there you go. So we can mix commands, we can have multiple arguments, and it all works fine. And let's just end this off by fuzzing to turn off all those LEDs because they are bright. And then let's check out what we've got next. So if I go back to the help menu for fuzzing, we've seen ramping, we've seen random, we've seen them mixed together with multiple arguments. Let's take a look at lists. So the way I like to show off lists is with the text display. So again, let's check out a new command. What does the text display do? P to enter text, or P and then enter text to display. Let's try to say, hello world. Okay, and we can see it's trying to pop up on the screen up here, but it doesn't quite fit. So one cool thing we could do is we could use a list to scroll this text across the screen. So let's try to type that up really quick. So let's go for fuzzing. Let's do P. We're going to repeat, let's repeat 100 times with 100 milliseconds. And now the argument's going to be a list. Now this is comma separated, not space separated. So we're just not going to add an extra space at the end before we close it off, which is why I kind of typed it out like this. But we know we can fit hello W. So let's keep this many characters and scroll through hello world. So we can go now. Hello, whoa, low, whirl, oh, world. And let's take a look at how this looks. Hello world, hello world. There you go. So there's an example of how you can use a list with the fuzzer. Last thing that we need to kind of get hands-on with and understand are going to be these two modifiers. We know lists, ramp, and random. Let's see how these modifiers work. I think the best way to take a look at them is in the main menu here. And I'm going to use SPI functions because these have specific formatting requirements. So if I want to write and read with SPI, it wants me to enter the data as a byte. So if I want to write 255, now that does fit within a single byte, but it is base 10, so I'm going to get invalid. So instead I'd have to write FF to get a success, and then I'm reading FF back because this is write and read and I've got nothing connected on the line. So how does this tie in with the fuzzer? If we want to fuzz W, let's repeat 5 times 100 milliseconds. Let's say I wanted to do a random value between 100 and 255. Well, if I wanted to do that, it's going to return values in base 10 between 100 and 255. That's not going to work. So what we can do is use those formatting commands. This time let's do W, and we'll do the same thing, 5, 100, at 100, 255. And let me actually copy this as well. But just at the beginning of this, let's say I want to format this as a single byte. So I'll use a caret, specify the number of bytes, and hit enter. And there we go. I read back FF every time, but this is what I wrote. Numbers between 100 and 255 formatted as a single byte. You can imagine this will look really similar if I were to use the ampersand, which is to format just in hexadecimal, because my values already limit me to 1 byte. See, it ends up working just the same. But a case where that wouldn't work is if we were writing multiple bytes. So let's take a look at that case. So this time, instead of writing between 100 and 255, let's write between the max value of 2 bytes, which is 65, 5, 35. So if we write this out, of course this isn't going to work, and I forgot to copy that. Darn it. Okay, let's type that out again. 65, 5, 35. So we know that's not going to work without a modifier, and you can imagine if we were to use the ampersand modifier, we'd get that in hex, but these aren't formatted as bytes, right? So still not going to work, still invalid. So what we'd have to do in this case is format as bytes, 2 bytes specifically. And if we send that, you can see now it comes out correctly as 2 bytes. We get 2 bytes read back every time. So that is sort of the use of these modifiers. So I hope that answers a lot of your questions about the fuzzer and gives you some cool ideas of what you can do with it. I think that's all I've got for you today, so thank you for watching.